Hello friends and hello student. My name is Ashok Sijala. In this session we learn the diagonal matrix or not in C language. So first I share my laptop screen and fix the position here so you can watch better my video lecture. And here Turbo C++ I double click and take some process, and now yes is open. Alt F file menu, take new file, and here our goal, write a program to given metric is diagonal matrix or not. So yes, a diagonal, that is our goal. So first in your mind question, what is a diagonal matrix? Yes, so let us check. So I question, right, what is a diagonal matrix? So yes, 2D array is known as a matrix array, or here what is a diagonal. So first I give one example. So like we can write in metric format. So 2 0 and second row, so it is a 2 by 2, and diagonal element other all are, that is 0, and that is known as diagonal matrix. So here the diagonal element is 2, here is 2, and here, and other all element are 0, that known as a diagonal matrix. So now we can check as so here that we can say that like x is that we have to define x, and now here also we can x or any other element. So here like 1, then 0 0, so that is a 3 by 3 square metric. Yes, that is a rules. Diagonal metric is always a square metric, so we can follow that rules in our C programming. And so let us check. Now I give the, so diagonal element other are all are rest of 0, that is compulsory, and that is a square metric, that is also compulsory. So like 0 0 and like here 3 or any other value, so that is a also known as a diagonal matrix. So diagonal here, like our diagonal element in the center, so like the first row, that is a here, that is middle, and then so middle we can say that observe this type of angle, so that is a diagonal element. So that is a non-zero and other all are zero, so that is known as diagonal matrix. So now you can understand what is a diagonal matrix. So now I can give in multi-comment line for your reference. So 2 by 2 and 3 by 3 square metric we have to check. So now I include our header file, standard input output, and on your console input output, and void main, and then we can define some integer variable. So let us check. Here I define like x 10 by 10. So we can scan 2 by 2 and 3 by 3. So that our I and j, there are two counter variable, then row and number of row and column. Yes, and one flag variable, so that we can use that check that given metric is diagonal or not. So first I scan, so enter number of rows, yes, that metric row and column. So first I can scan ampersand r and then copy and paste. So number of row and number of column. So that is our goal. So here we can scan as a C, and now what to do? So here now we can first check, yes, so that is a square metric or not. So how we can check? So that we can follow the rules. So R equal to C. So that is a our square metric. Row and column is same, and otherwise here we can say that this matrix invalid for, you can say that diagonal uh, matrix. So this matrix invalid for diagonal matrix. So that type of message. And here we can directly exit, yes, or if we provide yes, no exit, so we can just print which user provide the matrix, yes, that possibility. So first we can check, and here I provide first get ch, yes, that completes, so all are well. Now we can define, so input, output, and process. So we can first scan, yes, here first two for loop, and we can scan our matrix. So row and column is perfect, then we can scan. You can also scan before the row and column, but here I scan the first, and then I can scan. So row and column user implement perfectly. So that is a first condition must be the square matrix. So we can follow the rules. And now that is first our row, that matrix. So that index array you have to know very well that start with 0. And then inner there are 2D array. So two for loop is required, two-dimensional array, 2D array, that known as, and that is j is 0, j less than column, and j plus plus. Now with index we can scan, yes, that is my technique in always 1D array, 2D array, and multi-dimensional array. 2D array is also known as multi-dimensional array. So here x of percentage d and then percentage d. So we can scan with index, yes, ij, and now we can scan. So output that you can scan, that time also index is displayed. And now x of ij. So that is a now scan, and one row, then after provide slash n, because that is a two-dimensional array. So here one row complete, that we can provide the slash n. Now we can start our logic. So again, I copy this two for loop, and in if condition we can check, yes, that given metric is a so how to check. So yes, here we can very easily, yes, here you can look our example. So here diagonal element, so where the diagonal element, so here that we can say that I, that is our counter, I and j same, so that is our diagonal element, and rest of other are all 0. So we can provide the if condition. So here let us check. So first we can if condition. So I equal to j, so that is a row and column, so both are same. So we can check other if condition, and that is our x of I j, that is now our element equal to 0. So we can define as a flag 0, and other we can say that in else part. So that is the else part, yes, here else, and then also if condition, if x of I j, so that is a not equal to 0. So here we can not equal to 0. So all that I j, here is a 0, I and j. So that is a row and column. So if that is a diagonal element 0, so that we can flag is a 0, and not equal to other are all are 0, and we can provide the not equal sign. So other all are 0, but here we can provide the not equal to. So then we can flag equal to 0. So both condition, if anyone in this if inner if, here in if condition, nested if, and here else part if condition, so that metric is not diagonal, because here we can define that diagonal element 0, so our flag is 0, and non-diagonal element non-zero, so not equal to 0, so we can assign the flag is a 0. And when user enter here our if condition, that time we can define as a flag equal to 1. So then and then that metric is a we can say that diagonal. So now I can close first inner for loop, then outer for loop, and here if condition, flag equal to 1. Yes, so we can, if flag is 1 remaining, so we can say that uh, the matrix is, you can say the diagonal. Yes, diagonal matrix. In else part, if flag is 1, means 0, 1 is diagonal and 0 is not diagonal. So the matrix is not diagonal. And we can print, yes, here after else part. So here again, I copy note. So just not copy these two lines, but our for loop, yes, we can print. So that already we can scan. So I copy to for loop, and after the else part we can print also. So let us check. So here we can provide one message. So that is a slash and the 2D array elements are, yes, that type of suitable message, and we can print, not scan. So I remove this brace and just printf. And with index we can possibility, first I print with index and then I print in metric format, yes, possibility. So like in my YouTube channel you can watch multiplication of 2D array, symmetric metric or not, and transport metric. So metric programming is implemented in two-dimensional array, so you can watch all videos. That is better for your logic development in C language. So here we can print as index and also the print the element of x of I, j. So yes, and then we can provide one new line because that one row is complete, and then that is complete our for loop. So all as well. So let us I first save. So here we can say that diagonal matrix or not. So mat.c matrix. So yes, mat diagonal dia first three letter for diagonal words and metric three words. So diagonal underscore matrix. So yes, that already that file we can overwrite, no problem. And I compile, yes, any, yes, there is no any error. So perfect our logic. So let us check. So given metric diagonal or not. So we can testing these two examples. So diagonal means diagonal element is non-zero and other all are rest of the zero element. So we can define based on this syntax. So that is a square matrix. So first we can apply row equal to column, then and then we can apply flag equal to 1, and then we can scan. So otherwise that not scan. Just if row and column is not equal, so and then square matrix is a diagonal or not, we can check. So if that uh, means row and column diagonal element is a equal to 0, so that is a, we can say that so first we can check. Yes, here let us I compile and run. So 2 by 2, yes, and 2, then 0, then again 2, 0 and 2. So yes, that matrix is diagonal matrix because diagonal element. Yes, now we can 2 by 2, and now we can also blank one page so you look better, and next we can print in the matrix format. So first I can compile again and provide the 3 by 3, so 3 row and 3 columns. So 1, then 0 0, then 0 2 and 0, and next 0 0 and 3. So that is also diagonal matrix. So look, the matrix is diagonal matrix 2D array element R. Yes, so all like 0 0 1 1 and 2 2, I and j equal to that no, non-zero, and rest of all are 0. So but here we cannot I print as an index, so I now remove the index and print in the matrix format. So scan with index and print with index, that first part, and diagonal matrix or not we have to check. And now I can print in the diagonal metric, means a diagonal element, but not a diagonal matrix we can provide different metrics. So let us check. So first I not print in metric. First we can check. I give like sequence 3 by 3, but 1, 2, 3, 4, 5, 6. That is not diagonal matrix. So the metric is not diagonal matrix because diagonal element is a non-zero, but the rest of are zero must be. But here that not a zero all are. So that is a not diagonal matrix. So now how to print in the metric format. So yes, first in the uh, uh, inner for loop, we can print the that sign. So let us check. So that we can say that one symbol logical bitwise or not logical. So only one that symbol, and that I remove the index. So here I remove the index, yes, and before after one blank, and the here slash n we can provide this symbol. So that is a perfectly. So we can remove the index, and here I also remove ij, and only element we have to print and save, then compile. Yes, there is no any error, no any issue. So yes, I think you have to understand. So what is a diagonal matrix? So write a program to given metric is diagonal metric or not. Or we can say that check, yes, given metric is diagonal or not. So yes, given metric is diagonal metric or not. So that is a definition, and here I give the 2 by 2 and 3 by 3. That is a square metric, that is must be. So we can provide first if condition. Yes, I revise the logic. So here we can, if square metric, so flag assigned to 1, and then we can scan after that is a prove that row and column is a same. So then and then we can scan, otherwise we cannot scan. Yes, and so what to do if row and column is not a zero? So we can say that metric invalid for diagonal matrix. Yes, directly in go in else part. But that print, yes, here I also check that condition, and that metric is also print. Let us check. I compile, then so here I give like uh, uh, 3 row and 2 columns. So that is a not proper for diagonal metric. So let us check. Yes, here that is not scan. The metric invalid for diagonal and all are zero is printed. So here we can say that not, and yes, here in message that double E. Yes, I remove this one E. Yes, perfect. So if row and column is not same, so we can directly give the message. So here we can say that this is invalid for diagonal matrix and all are zero. And if you print or scan also, but here we cannot scan that. That is a very important. So only this condition is just and also if you not zero only print the message. So here provide again that is a if condition, or we can say that if condition. So what to do? So here we can say that if row flag is here we can assign that is a like but here is a already inside the one. Yes, here we can provide inside the flag one. So outside we can row and column fixed, then and then we can print. Yes, so we cannot provide any if condition. Yes, no require here. That all are zero is by default is print. If not any value we have to pass out. So that is better. Yes, now we cannot any improve our logic. So you can print also that possibility. Here we can outside flag is assigned to 1 here, and that we can print if flag is a 0 or not. So that we can print only just for your reference. So yes, here then we can scan. Yes, that is a scanning to for loop. That is very easy. But now we can again that same for loop and diagonal that I and j is same. So that element is diagonal, and we can check if that is zero. So we can flag assign to zero because that is not zero. And else part other element. So not diagonal element not equal to zero. So then we can flag assign to zero. So that is a flag is remaining 1. So that is a diagonal element, and flag is assigned to 0 in if any in this if condition is if is true, so that is flag is 0, and in else part not diagonal element is not equal to 0, so that we can assign to flag equal to 0. So you can understand the definition of a diagonal element is non-zero and rest of all are zero, that known as a diagonal matrix in mathematics. So that is a definition of what is a diagonal matrix. So here given metric and must be the square metric. That is also we can follow the rules in this logic. So now let us check. I compile, yes, and now I print 2 by 2 and first give any like a 9 and 0, and we can say that 0 and 9. So yes, look, the metric is diagonal metric, or we can say that given metric is diagonal metric. That is message, and we can print in the metric format. Yes, here look, the 2D array element are, yes, and metric format perfectly print. So now we can check 3 by 3 square metric. So yes, and here I give any element like 1, that is our diagonal, so non-zero, and rest of are 0, and then 0, I give any like 1 and 0, then 2, 0 and 1. So and let's look, the metric is diagonal metric because diagonal element is non-zero and rest of all are 0. So that given metric is a diagonal metric. So yes, I hope you can understand perfect, I simple. And here also that possibility you can dynamic 2D array. So if you not understand malloc, calloc, and free function, you can use malloc or free or calloc or free. So you can watch in my YouTube channel dynamic 2D array and then apply to this diagonal metric or not in the dynamic array. Yes, that possibility. So here we cannot provide a static 10 or 10 row and column, and then we can scan. But you can malloc and calloc and free function must be used. But here I not use in this session because already I take so many my video previously in metric programming, that is two-dimensional array. So yes, write this program to your C notebook. Very simple and interesting concept. Here we can take simple if else and in if condition. So that check the given metric or diagonal or not. So I hope you can understand, and we can also print in the metric format. So last our output you can see Alt F5 I can press, so you can see your previously last output. So that is a diagonal metric. So now I can close Alt F3 this file and quit. So subscribe my channel Ashok Sijalakane, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.